All right, so starting from here, we'll go to beginning with data blocks. And we're going to build on what we've just done there. I just wanted to go through that again for you. So let's go forward. So what I'm going to do quickly in this session is just give you a rundown of the 3 basic data blocks that I normally include in a project. And that would be a global data block. It could be called global or DB global. And I normally use DB1 for that. DB2, this control relays is where we do instead of using markers, I create what they call control relays. And parameters is where all the other control parameters of your project will be. And it's nice to put it in its own DB. All right, and then we'll talk quickly about some SCADA screen design and what we're trying to achieve. And then from there, we're going to develop what we call areas of the plant. And just to find out, when you're looking at a particular area of the plant, how do you know it's running or it's not? And the second thing, how do you know if there's another area which is running or not, and whether there may be a problem with that area? And then I'm going to go to the last part, which is what I call the safe start concept. And it's basically how we're going to start up each area of the plant using a siren and a safe start period. And then there's a reset function. Okay, so let's go to DB1. Like we spoke previously, you remember we used marker byte 0 for these specific flags, the 0, the 1, and the simulate and bridge. I actually want to make sure that we standardize in using DB1, and forget about marker byte 0, because as we say, markers are dangerous. So we will in future be talking about using the DB. The other part here, which I've got in from a standard project, is sometimes we want to build a flasher to flash a actual light or something once a second. We've got a standard flasher circuit for that. And there's some alarm triggering, and this part here has to do with the safe start siren. And you'll see there's another one here which is called the rotator. This is a little functionality we normally build into a project, which will be running in the PLC. There'll be a number counter in the PLC, and on the actual SCADA screen, you will see somewhere in the corner of the screen that you'll see it changing. It'll either be rotating or it'll be showing a number, just to show you that communications is active between the SCADA and the PLC. Because sometimes when you're looking at SCADA and it looks like nothing's happening, this is what's going to tell you whether you actually got live information or not. So anyway, let me just go quickly to DB1 here. Let me go to another project. Oops. And I'm going to go to DB1. And there is a standard DB. And yes, we can have a whole lot of other states in here. But basically, this will be global information that is used throughout the project. So you can see this is pretty much the same as what it was on my screen. But what I want to go to is the next thing. Because there's another interesting problem in Siemens. Remember I asked you before to go and look up what ASCII is? ASCII, it's American Science Communication Interface Standard or something like that. But this is the ASCII table, the standard ASCII table. And it's a way that a computer represents characters. So I just want to show you some special characters. Just consider the null. If the register or the byte in the PLC, sorry, I want to go back, has got a 0 in. As far as a string is concerned, that is a null string. It doesn't have information in it. So typically when you have a comms link between two things, if there's nothing happening, it can transmit zeros, which is technically null, which means nothing is happening. There's a little bit more complicated than that, but if you ever get zeros, means there's no information, null, nothing. The next thing I want to show you is just look at the ASCII characters for numbers. A number 0 is actually hex 30. 30 in hex is actually 48. That's 3 times 16 plus 0 times 1, 48. And then 1 is 31, 32, and 39. Ah, Tepo has arrived. Tepo is there. All right, so the ASCII characters for numbers start at 30 in hex. Now look here down the bottom, 40 in hex, or 41 technically, is the ASCII for capital A. So actually 4 times 16 is 64, plus 1 is 65. So all the capital letters are all like this. Then it has some brackets and things, and then the smaller letters that start at 61 hex. So 6 times 16 is 96, plus 1, and they're the ASCII characters for the lowercase letters. And there's one more which is quite specific, is the space. Space is not null. Space is a character, and it is character 20. So when you build a string and it's got spaces in it, it's actually putting this character in there, not nothing. So it doesn't look like word, it's actually a character. So let me go quickly to my DB1 in this project. And I'm going to actually build a little string here, because I want to show you what happens with strings. I'm going to even zoom so we can see it. Oh my goodness. So if I want to add something to this DB, you can see it starts at 0 and it goes all the way to 8. This is an integer, so it's 2 bytes, 8 and 9. And the next part is going to start at 10, and I'm going to put in a P type here, a product type, which we use a lot in milling. So let's say I call it P type cake, and I'm going to make it a string, and I'm going to allow 8 characters. And I'm just going to put in 2 quotes like that. Now notice what has happened. Although I said 8 characters, it's actually using 10. Now that's very important for us to understand, because the actual string has two numbers in front of it, which tell you the actual maximum length of the string and then the actual length at the moment. So if I go to my value table here and I call up another value table, because I've built it for us, that number 4, you can see here now I've actually got each byte as a separate byte. So from 10 to 20, now you see I've made the first 2 decimal and the next 8, which is the actual string, as characters. Now you can see the first byte is now telling us it's expecting a maximum string value of 8, and it has nothing in at the moment. The length is 0. See, it's got character 0, or code or hex number of 0, which means there's nothing. And the hex value you can see is also 0. So if I go back to my DB here and I go and put in, if I make it Tim here, or let me make it even like that, and I then save it and download it. If I go back to the value table, look what's happened. In this VAT table, it's showing us the character T, and look there's the ASCII code 54. And the I is a 69, it's ASCII code 69, and M is 6D. So let me go back to my ASCII table, T, capital T there, 54. See, 54. I, which is a lowercase I, hex 69, 69, and M is 6D, it's 696 plus D is 13, and there is the D. Okay, so you see, now we actually haven't given it a length. That is interesting, it should have put it in there automatically. I'm going to just go back here and I'm going to add, I'm going to make this actually cake now. And I'm actually going to do it like that. See, now I've made it cake. The code is actually 4 characters long. You see the nulls here? This should technically be a 4. Murphy's Law, don't demonstrate. And that is how the actual string should be represented in a Siemens PLC. Now you can see this is a lot of hieroglyphics and gobbledygook. Siemens PLC was not designed for strings, it was designed for bits. So when we are working with strings in Siemens PLC, it becomes very difficult to work with strings. We're working in characters. So let me go back to here. So there is technically how the string should be stored. There is the maximum length. The actual length would be a 4. We've got a C, an A, and a K, and an E. Now that's Excel, should have a double quote, but anyway, and those are all nulls. Everybody understand how strings are stored? They are difficult. They are difficult. All right, the reason why I wanted to show you that, because how do you compare, how do you tell if say you have a plant where you've actually got a product type you want to select and you want to check that the bin has got the same product in it. If you had comparing strings, do you now compare byte for byte? Do you compare byte 12 is equal to the same character as that one, same, or do you use some other method? Now, Siemens has got a string function. It will just tell you that they're equal or not. It won't tell you where the difference is, but it does have such a feature. And I'm going to go back to my PLC quickly. I'm going to zoom out here, back to 100. Go back out of here. I'm going to go back to the example here. I'm going to quickly go to a reference table quickly because I know where it is, and I'll show you later. DB2. If I go to this one, there is supposed to be a tag. No, it's not helping us. Let me call up DB2 here. In this plant, this is Siemens. It has a flag here which says the product type is equal to white bread flour. So I'm just going to go back to my cross-reference and I'm going to look for that tag. That's one place it's used. I'm going to just open this up. Up. No. Control relay 5. It's not helping us. No, it's not helping us. Yep, control relay 5. You see how I've actually got the function block. This is a standard function block from Siemens. So you compare a product type tag with my global, and it gives me one flag, which tells us it's equal. And this command then does that, whatever that function is. So you can see strings are not that easy to work with. I just want to close this here quickly. Okay. I just got a message from Zoom that the meeting is about to finish. It's got a time limit, so I'm going to just run through this. If we get knocked off, I will continue the session next time with the next step. Let's maybe finish this part. Okay. Now the second or the other two standard DB blocks that I wanted to interest you in is what I call DB2 and DB3. So DB2, I've actually built a blank DB2 here. Remember I said to you before, let me go here, that markers are a no-no. Because every Tom, Dick and Harry knows markers, they come and fiddle, they just start using markers, don't know what's going on. So we're going to control what we do in our program by putting a DB together called DB2, which has got just a list of bits in it, and I've just made 8 bytes of control relays, which gives me technically 64. So I can then, as I program, I can say I want to use this bit to say Tim is great. So then, oops. So you can add a comment to this DB, and you can say start plant now. So if you've got certain conditions that you want that need to all be true before you start the plant, you can then set this DB2 bit 0.2 on, and then it will tell the rest of the program to start the plant. Now, I don't technically have to download the changes to the comments. If you do, then it resets them all back to 0. But if I can go back into my PLC, I go back to OB1, I'll just go to a new rung here, go Control R. I just press db2.control_relay001. See there it says db2 control, but if I move the mouse over it, there's the comment I put in. You see that? So if Tim is great, then we can start the plant. So let's go control relay 02, and there is my logic. Oops, why is it not helping me? See, start the plant now. So whatever I do now, I can use this tag anywhere in the PLC, and it's not reflected in the markers. Does everybody understand that? We're not using markers. Here we have control of what these bits are doing. All clear? Oops, and my PLC has crashed. Why is that? Because I haven't loaded DB2. Let's go and do that. Let's go download that. Let's see if I can start my plant, my PLC. There we are. There it is, it's running again. You see what happens with DB, see what happened now. That is exactly what Siemens has now. It didn't have DB2 in it, so it failed. It literally didn't like that. So there's my program running again. Everything's happy. I'll make that a 1. Now literally I could take this logic out, and those 2 bits would stay on all the time. If I go to my DB2, and I monitor this one, you see they're on. Now this is another thing which is very odd with Siemens. I cannot get this column to extend. It is annoying. Anyway, that is just now. But there we are. So we will rather use control relays for our markers, and that's just a tool that I use. So let's go back here. Right, parameters. Now, generally, when you have some control mechanism, you may have something like a pressure, which has got its own scaling, which says 0 to 100%, which is 0 to 10 bar or 0 to 100,000 kPa. But depending on what phase of the process you're in, you want the set point to be 6 bar when it's ramping up, and then when it's cooling down or something, you want the set point to be back at 2 bar. So you would then set up different set points for different parts of the process. So what I would then do is I would then create a new DB called DB3, which is my DB params. And then if I open up DB params, I can literally go and put there, say PT101 set point. Stage one, and that could be a real, and that might be 6.2. So that is the set point. And then if I want another set point, PT101 set point stage 2. It's also real, and that might be 2.5 bar. So literally then you can, from the screen, you can put up a screen where you can actually change these parameters without having to go into the PLC and change code. So parameters are very useful when the control function changes. And there we have it. There's the 6.2. And Siemens is very good on reels. One thing which I must say, the reels work very well. So it is fully IEEE compliant, as they call it. And you can adjust it here. You can put it in a VAT table. Let me go back to my VAT table. Let's make another VAT table. VAT number 5. Let's call up VAT number 5. Let's go quickly db3.dbd0. See what I did? I made dbd0. Remember I told you the first time a reel is a double block doubles. It says hex. Let me change that to floating point. And the next one will be at where? dbd4. If I go to hex here, not hex, sorry, floating point. Monitor it, there's my 6.2, so I can make that 6.334, and if I write it, there it is. So reels work very, very well in this parameters DB. You would also, if you had those timers, you would then be able to literally have the timer preset and the timer actual in this parameter DB. So if I wanted to say have start timer, time preset, and that's an integer, remember, and that will be, say, 300 seconds. I can even put the actual here, so let me go and put the actual. Int, and it's always going to be 0. I save that quickly and download it. Now what's going to happen to those values in that? They're going to go back to those values, aren't they? There they are, they're going back. So let's be a little bit careful with this DB as well. But now when in your control program, you can use these two to control that timer without having to find a marker word to put it in. You don't have to find a special DB in your sequence. You've now got a separate area to put your parameters. That is what we use typically a DB like this for, is global parameters.